Okay, hi guys. Welcome back to academic year 2020-2021 and congratulations for passing your second year in Bachelor of Science in Medical Laboratory Science. So, congratulations. Nasa third year na kayo ng pagiging medtech student. So, our subject today is about clinical chemistry 2, of course, and our topic is about the liver function. So, for the liver function, we'll have the lecture discussion and the separate discussion for the laboratory part. The objective of this chapter for you guys is that upon completion, the clinical laboratorian or you, my dear students, will be able to do the following. First, that is to diagram the anatomy of the liver, the gross anatomy, or you should know where is it located. You explain the functions of the liver, the bile secretion, synthetic activity, and detoxification. List two important cell types associated with the liver and state the function of each. And define jaundice and classify the three different types of jaundice. So it was not listed here, but also to determine what are the derangement of bilirubin metabolism and what type of bilirubin is increased in this disorder. So guys, this is the flow of our discussion. We will discuss first the gross anatomy, followed by the microscopic anatomy of the liver, the biochemical functions. There are four main biochemical functions that we will discuss today. Bilirubin metabolism, the derangement of bilirubin metabolism, the causes of elevated, the, the diseases that cause an increased serum level for both unconjugated and deconjugated bilirubin, and the liver alteration that happens when there is a disease of the liver. Guys, for the participation part, please take down notes in a notebook. Okay, so that is the instruction. You take down notes in a notebook and then just like before, you will take a photo of that and you will upload that in our LMS, and that is already your class participation for this topic. Okay, so that will always be our method for the class participation part, which is 20% of your total grade for the lecture. Okay, so 20% class participation, 30% quizzes, and 50% for your major exam. So, please lang, magsulat kayo. Okay? And can also use that as your review material because I will not give you a copy of this PowerPoint presentation. Okay, so we'll discuss first the liver. So the liver is the largest and is the most complex organ that is found in the gastrointestinal tract. So the liver that is composed of three systems, the hepatocytic system, the biliary system, and the RES, or the reticuloendothelial system. The hepatocytic system is concerned with metabolic reactions, macromolecular synthesis, which includes the protein synthesis, as well as the degradation and metabolism of xenobiotics, or the drugs. The biliary system, okay, it involves the metabolism of bilirubin and bile salts. While for the reticuloendothelial system, okay, it is concerned with the immune system and the production of heme and globin metabolites. So, the cells that are responsible for the function of the reticuloendothelial system are the Kupffer cells. These Kupffer cells are a form of macrophage that are involved with the immune system, including being a major site of defense against intestinal bacteria and the primary location for removal of antigen-antibody complexes from the circulation. So the liver is the largest internal organ, which is also a functionally complex organ. It plays a critical role in metabolism, just like in carbohydrate, protein metabolism, as well as in lipid metabolism, digestion, detoxification, elimination of substances from the body. Okay? And the liver, one of the unique characteristic of the liver, it is that it has the ability to regenerate. Okay? It has the ability to regenerate cells destroyed by short-term injury or disease. So now we go to the gross anatomy of the liver. When we say gross anatomy of the liver, we are discussing the macroscopic anatomy. So macroscopic anatomy, that is the anatomy, okay, or the feature that is seen by the naked eye, as compared to microscopic anatomy. You can see that feature or the characteristic by using a microscope. So we have here the liver that is depicted in the upper right quadrant. Okay, so the liver, that is a large and complex organ weighing approximately 1.2 to 1.5 kilogram in a healthy adult. So it is located beneath, we have here the diaphragm. It is located beneath the diaphragm, okay, and it is also attached to the diaphragm. Okay, it is protected by the lower rib cage. So as we have mentioned, it is a complex organ. But regardless of its complexity, okay, the structure is actually relatively simple. Okay, it is divided into, okay, unequal parts. Why unequal? Because the right lobe is 6 times larger as compared to the left lobe of the liver. Okay, it is divided by the falciform ligament. So we have it here. Okay, and below the liver, we have there the gallbladder. So we have here a closer image of the liver. So as you can see here, guys, that is protected by the lower rib cage. Okay, and it is very noticeable that the right lobe is a lot larger or much larger as compared to the left lobe. And take note that it is divided by the falciform ligament, and we have also there, but this is not a part of the liver. This is another organ. We have there the gallbladder. So again, the right lobe is approximately 6 times larger as compared to the left one. So this is extremely vascular. What do you mean by vascular? It receives a lot of blood supply. Okay? And it receives blood sources or blood supply from two different sources. First is the hepatic artery, and the second is the portal vein. Okay, so again, the liver receives blood from the two sources. So we have here, this is the hepatic artery. Take note, guys, that the hepatic artery supplies 25%. Okay, 25% as compared to the hepatic vein, which supplies 75%, okay, of the blood that is received by the liver. Supplies. So if you remember, we mentioned that the liver is functionally complex, okay, because it performs a lot of function. Okay. However, structurally, it is actually simple. So as you can see here, guys, we have lobules. So this a lobule is a six-sided structure with a centrally located vein and portal triad. So this is one lobule. So on the center, we have there the central vein, and on the outside parts, we have there the portal triad, which contains the hepatic artery, portal vein, and the bile duct. Take note, guys, that the lobules are the functional units of the liver. Okay, functional units. this is the counterpart of the nephrons in the kidney, right? Because the functional units of the kidney are the nephrons. But when we are speaking of the liver, its functional units are the lobules. So the liver is divided into microscopic units called the lobules, which are six-sided structures. So these lobules are responsible for all metabolic and excretory functions performed by the liver. So there are two major cell types that are found in the liver. We have the hepatocytes. So we have here a more detailed structure of the lobule on the edge part. Okay, so this is what I am referring as the portal triad. So the bile canal, okay, or the bile duct, I should say, the bile duct, the portal vein, and the hepatic artery. So that is the portal triad. So the hepatocytes, take note, or as you can see here, they are labeled as the hepatic cells. These hepatocytes makes up about 80% of the total volume of the liver. So these hepatocytes, these are these are large cells that radiate outward the central vein. So we have here the central vein, or this is the central canal, which contains the central vein. So we have here the hepatic cells that radiates outside the central vein. Okay, so these cells perform the major functions associated with the liver and are responsible for the regenerative properties of the liver. Again, when say regenerative, they can be formed or they can be created again. So on the other hand, we have here the Kupffer cell. So as you can see here, it is not the correct spelling because Kupffer, that is Kup and then ER. Kupffer cell, which are the macrophage found in the liver. So these Kupffer cells, they line the sinusoids. Okay, they line the sinusoids of the liver, and they act as active phagocytes capable of engulfing bacteria, debris, toxins, and other substances flowing through the sinusoid. Again, the liver has a regenerative capacity where it wherein it can regenerate, it can be formed again, or it can be created again to its former size in 6 to 12 months. Okay, this is in cases wherein there is a surgical removal or loss of 80% of its mass, it can still regenerate. So now we discuss the biochemical functions of the liver. So the liver performs four major functions, namely excretion and secretion, metabolism, detoxification, and storage. Although the liver is responsible for a number of functions, this chapter will focus only on the four major functions that have been mentioned previously. Okay, so we go to the first biochemical function, the excretory and secretory function of the liver. Take note that the liver is the only organ with the capacity to rid body of the heme waste. This heme waste is actually from the red blood cells. Take note that red blood cells are made up of hemoglobin. Okay, this hemoglobin is broken down into heme and the globin chain, okay, as well as iron. So, the bile is made up of bile acids or salt, bile pigments, cholesterol, triacylglyceride, and phospholipids. Bilirubin is the principal pigment of bile, okay, and it is derived from the breakdown of the red blood cells. So the role of the bile is to emulsify fats, break them down into smaller pieces, and distribute them throughout the watery intestinal contents. The bile is actually a digestive juice that is made in the liver and stored in the gallbladder. Take note that the major function of the bile is in fat digestion and absorption of that fat in the intestine. So like for example guys, you had a very fatty meal. So kumain kayo sa samgyeopsal, sobrang daming fats ng kinain nyo. Take note that those fats, okay, they cannot be absorbed in the small intestine, okay, by itself. The fats cannot be absorbed in the microvilli in the small intestine unless it is broken down by bilirubin. By the bile. Okay, so when you take in fatty um, a fat-rich meal, those fats are then broken down by the bile with the help of the pancreatic lipase. The fats will then be broken into monoglycerides and fatty acids. These monoglycerides and free fatty acids are in the form already that can be absorbed by the small intestine. So that is the major function of the bile. Okay, so it is in fat digestion and the absorption of that, and it enables the absorption of fats in the small intestine. The bile is not excreted in the feces because it is recycled. Okay, it is recycled by the enterohepatic circulation. So the second biochemical function is metabolism. So we have different types of metabolism that is carried by the liver. We have the carbohydrate metabolism, lipid synthesis, and the protein synthesis. In the carbohydrate synthesis, the liver maintains a stable glucose concentration by storing it as glycogen and degrading glycogen when needed by the body. Okay? So the liver has an extensive metabolic capacity that is responsible for metabolizing many biological compounds, okay, like the carbohydrates. So take note that if we have an excessive amount of glucose in the circulation, so it will then be converted, or it will be stored in the liver in the form of the glycogen. In cases wherein there is a low blood sugar in the circulation, okay, so the level of the blood sugar is low, the liver can break this glycogen so that the glucose will go into the circulation. Okay, therefore the liver, okay, has the capacity to maintain a stable level of glucose within our circulation. So in the lipid synthesis, liver breaks down fatty acids to form triglyceride, phospholipid, or cholesterol. So lipids are metabolized in the liver under normal circumstances when nutrition is adequate and the demand for glucose is being met. So the liver is responsible for metabolizing both lipids as well as lipoproteins and is responsible for gathering free fatty acids from the diet and those produced by the liver itself. Okay, so contrary also to what many individuals know is that cholesterol, majority of the cholesterol, actually approximately 70% of the daily production of cholesterol, okay, is actually made by the liver. Okay, so mostly of the cholesterol that is present in our body is made by the liver. So third, protein synthesis. Almost all proteins are synthesized by the liver except for the immunoglobulins and the adult hemoglobin. So question, what cell synthesizes your immunoglobulin? So 5, 4, 3, 2, 1. We have the plasma cells. So these plasma cells, they are the cells, these are actually B cells or more advanced type of B cells that are existing to mainly create immunoglobulins or antibodies. And how about the adult hemoglobin? Okay, what synthesizes the adult hemoglobin? So you think about it in 5, 4, 3, 2, 1. The adult hemoglobin are actually synthesized by the red blood cells. Okay? And aside from these two, immunoglobulin and adult hemoglobin, there is another protein that is not synthesized by the liver. Okay? So this part was actually taken from bishop, okay, this immunoglobulin and hemoglobin. But in addition, there is another factor, okay? So, or protein that is the von Willebrand factor. Von, B-O-N-W-I-L-L-E-B-R-A-N-D factor. Von Willebrand factor. So, it is made by the endothelial cells which lines the surface of the blood vessels as well as the bone marrow. So it is not the liver that makes these three proteins, immunoglobulin, which is made by the, again, what cell? Plasma cell. Adult hemoglobin, which is synthesized by, okay, red blood cells. And von Willebrand factor, which is synthesized by endothelial cell. Okay, so the liver plays an essential role in the development of hemoglobin in infants. Okay, that's why it was mentioned here as adult hemoglobin. Okay, because um, in in an infant or even in a fetus, okay, when the baby is still inside the womb of the mother, the liver is also involved in red blood cell formation or the erythropoiesis. Okay, but not for the adult hemoglobin. Okay, the liver is not involved in synthesizing the adult hemoglobin. So one of the most important proteins synthesized by the liver is the albumin. So the albumin, which carries with a wide range of important function. One of the great function of the albumin is that it it maintains the um, osmotic pressure inside the circulation, okay, as well as it is a transport protein for the unconjugated bilirubin. Take note, it is a transport protein for the unconjugated bilirubin. So another um, function of the liver related to protein synthesis is that the liver is also responsible for synthesizing the positive and negative acute phase reactants and coagulation proteins. And it also serves to store a pool of amino acids through protein degradation. And we also have the third biochemical function. So we have the detoxification and drug metabolism. So the liver prevents toxic or harmful substances from reaching systemic circulation by binding or chemical modification. Therefore, guys, the liver serves as a gatekeeper between substances absorbed by the gastrointestinal tract and those released into systemic circulation. Okay? In other words, every substance that is absorbed in our gastrointestinal tract must first pass through the liver, okay, before it goes through the circulation. This is an important function of the liver because it can allow important substances to reach the systemic circulation, and it can also serve as a barrier to prevent toxic or harmful substances from reaching systemic circulation. Okay, that's why in cases of poison, okay, in poisoning, okay, or even in drug overdose, the affected organ is the liver because it tries to detoxify. Okay, it tries to detoxify the poisons. Okay, and toxins. Okay, so yun po yung nangyayari in the liver. So, detoxification and drug metabolism, liver. So, any drug that you take, so you're going to take aspirin, paracetamol, of course, if that is orally, okay, if that is orally, it goes down into the intestinal tract, and after it is absorbed in the intestinal tract, it will go to the liver for detoxification purposes. And last of the function here, we have the storage. Okay, so the liver can act as storage organ for vitamins, minerals, and glucose. So glucose, this is very well known in the form of glycogen, right? So the liver acts as a storage site for these substances. So the liver provides a vital source of energy of the body, which the liver, wherein the liver transforms the glycogen, okay, for more efficient storage. The liver also stores vitamins and minerals for the times when they may be lacking in the diet. Glucose stored in the liver is called the glycogen. So the glycogen is like, actually the glycogen is a backup fuel wherein it is broken down into glucose when the body needs a quick energy boost, okay, or when the blood glucose level is low. So in these cases, the glycogen is broken down and is released into the bloodstream. So this is the first part for our lecture. I will end the discussion here. I will create the next video related to bilirubin metabolism and the derangement of bilirubin metabolism that causes an increase in conjugated and unconjugated bilirubin in the next video. So I hope you learned a lot from this first lesson that we had in Clinical Chemistry 2. Okay, simula pa lang po to. Wala pa tayo sa kalahati. Out of 50 slides, we were only able to cover 19 slides. So we still have 31 slides left to discuss for this topic, the liver function. And take note that we are only discussing the lecture part. So hindi pa natin naabutan yung laboratory part. So I wish you well, guys, and God bless.